So test tomorrow is 9.4 and 9.5. 9.4 was the quiz that you had to graph and eliminate the parameter. And then 9.5 is the new stuff. All right, so let's look at number 1. So this is quiz stuff. So first thing we want to do is graph. We have to plug in t. We're going to find our x value, find the y's, and that gives us points x comma y. So what's the first number I'm going to plug in for t? -1. A lot of people forgot to plug in the first number on the quiz. So we're going to plug in -1. We have -1 plus 9. So that would be 10. And then 5 times -1 squared minus 5 would be 0. So I'm going to graph that. I'm actually going to wait before I graph all my points just to kind of see what my increments need to be, how big my numbers are. What number would I plug in next? 0. So -0 plus 9 would be 9. So the first number is 9. Then I have 5 times 0 squared minus 5, which would be -5. Then we plug in 1. So -1 plus 9 would be 8. 5 times 1 squared minus 5 is 0. Then we plug in 2. So -2 plus 9 is 7. 5 times 2 squared minus 5 would be 20 minus 5, so 15. Then we plug in 3 and 4, so 3 be -3 plus 9 is 6. I'm going to plug in 4 at the same time, so -4 plus 9 is 5. So 5 times 3 squared minus 5. 3 squared is 9. 9 times 5 is 45. Minus 5 would be 40. And then 5 times 4 squared minus 5. 5 times 4 squared would be 16. 16 times 5. 75 minus 5 would be 70. So it should be 80 minus 5, which is 75. All right, so when we plot our points, my x-axis is going to go from 5 to 10. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my y-axis, the numbers get pretty big. So I'm going to do increments of 10 just for the space, but you guys could do whatever you want. You did pretty good with graphing on the quiz, whether you did increments of 5 or increments of 10. Let's go to -10, we could say here, and then 10, 20, 30, 40, 50, 60, 70, 80. So my first point is 10, 0, so I'm going to go to the right 10. Stay at 0. Then to the right 9, go down to -5. And to the right 8, stay at 0. To the right 7, go up 15. To the right 6, go up 40. And then to the right 5 and go up 75. So my graph has this shape. And we started here at 10, 0, and then went down. So just make sure your arrows go in the direction of the points that you're plotting. Your graph doesn't have arrows at the end because it's not like a parabola. It's just from -1 to 4. So don't put a 0 at the end. It's just from here. So you're going to have a closed circle here and a closed circle here. Next, we want to eliminate the parameter. So I'm going to solve my x for t to make the x equation t equals. So I have x is equal to negative t plus 9. So t is equal to 9 minus x. So since t is 9 minus x, I'm going to take that and plug it into the t in my y equation. So y is equal to 5 times 9 minus x squared minus 5. You can leave it like this. That is okay. If you decide to simplify and you want to FOIL this out, don't forget to FOIL, then distribute the 5, then subtract the 5. A lot of people lost points because they continued to simplify, but simplified wrong. All right, let's look at 3. We have to match the polar coordinates with the point on the graph. So I'm going to start by looking for my 5 pi over 4 for theta. So 5 pi over 4 is going to be here. And then negative 1 means that I go in the negative direction. So I'm going to continue that line this way. Just draw a straight line. So instead of going positive 1, 1 ring that way, I'm going to go 1 ring in the opposite direction. So this would be my point. This is negative 1, 5 pi over 4. So if your r is negative, you just are going backwards 1 ring. All right, the second part of this question says we have to find the rectangular coordinates of this point. So to find the rectangular coordinates, we have to convert it. So you have to know your 4 little formulas. There you have 2 from going to rectangular to polar and 2 for polar to rectangular. So our formulas are x is equal to r times cosine theta and y is equal to r times sine theta. So x is equal to negative 1 times cosine of 5 pi over 4. So I'm going to use my unit circle to figure out what cosine of 5 pi over 4 is. Cosine tells us we look at which number, x or y? X. So it'd be negative square root 2 over 2. So negative 1 times negative square root 2 over 2, which would be positive square root 2 over 2. Any questions on how we found that? Let's do the same thing for y. So negative 1 times sine of 5 pi over 4. Sine tells us that we have to look at the y value. So our y value on the unit circle would be negative square root 2 over 2. So we would get square root 2 over 2. So our coordinate point is square root 2 over 2, comma, square root 2 over 2. So if we plotted this point on a rectangular coordinate plane, it would go to the right and up, which puts us in the first quadrant, which makes sense because our point here is in the first quadrant. So if you had something that was like negative square root 2 and negative square root 2, that puts you down here. So one of your points may be off. So you can always check because they're going to end up in the same spot. It's just, you can see that these are both positive, so you're going to be in the first quadrant here, just like our polar point is. Let's do number 4. So we have to plot the point given in polar coordinates. So we're going to go to 2 pi over 3. So 2 pi over 3 would be here. I'm just going to extend it all the way through just in case. But it, again, just drawing that line is just kind of for your work, just to see where you need to go. So then I have to go out 2 rings. So from the center, from the pole, I'm going to go out 2 rings. So that would put me right there. So that would be my point. The second part of this question says we have to find 3 additional polar representations of the point that theta is in between negative 2 pi and positive 2 pi. So we can't just keep adding 2 pi each time. We got to stick within these parameters here. All right, so let's find additional polar representations of the point. So we have, I'm going to rewrite it over here, 2 and 2 pi over 3. What's another point that gives us the same one, another coordinate that ends up here? Perfect. So you're saying we go to 5 pi over 3 and negative 2, which means we go backwards 2 rings, which puts us in that same spot. Awesome. So negative 2, 5 pi over 3. That works. Yeah, so we would go to 5 pi over 3, but instead of going in the positive direction, we just go backwards because it's negative 2. What else? How did you find that? Perfect. So if we keep the same number here, we can keep negative 2. And from 5 pi over 3, we would subtract 2 pi. If you change the sign, so if you're using this one, and you change the sign to negative 2, you can add or subtract pi. So if we change the sign, so going from this one to here, we change the sign to negative 2, we can subtract pi. So we have 2 pi over 3 minus pi, so make that 3 pi over 3, which gives us negative pi over 3. So if you change the sign, you add odd amounts of pi. So you can either add pi or 3 pi or 5 pi. So if you change the sign to negative, because we started off with positive 2, you add or subtract an odd amount of pi's. If you keep the sign, so if we keep this as 2, so that's the next one we're going to find. Let's keep it as 2. So we keep the sign. We're going to add or subtract what? 2 pi. So we add or subtract an even amount of pi's. Would I add or subtract here? Why subtract? Because then it would be too big if I added 2 pi. So I'm going to subtract 2 pi because you can do either or. So I'm going to make this 2 pi over 1 to change it to 6 pi over 3 just so we have a common denominator. So that gives us negative 4 pi over 3, which is still in between our negative 2 pi and positive 2 pi. So these would be our 3 additional points. So we want to plot the given polar coordinates. So we start with a negative theta. So I want to either find the positive coterminal angle to it, or you can see like how many spaces you go away from 0 in the positive direction. So we would go from here to here to be positive 7 pi over 6. So you would do the same amount but in the negative direction. So we would start at 0, go around pi and 2 more. So that would put us here at 5 pi over 6. So you could either do it by looking at it, or you could find the positive coterminal angle. How would I find the positive coterminal angle? We add what? 2 pi. So we would just make this 12 pi over 6. When we add, we get 5 pi over 6, which is where we ended up there. That would be a 5 pi. So we found that we're looking at 5 pi over 6. So I'm going to highlight that line there. And then because it's negative 1, we're going to go in the opposite direction. So instead of going out 1 ring, I'm going to go in the opposite direction, out 1 ring. So about there.
So if it would have given you a positive one, you would have just stayed there.
Yeah, so we would have gone in this direction if they were positive, but we have to go in the opposite direction since they're negative. So this would be our point. So the second part of this says to find the corresponding rectangular coordinate. So we're going to convert it. So again, I'm going to use my formula. X is equal to r times cosine theta. So x is equal to negative 1 times cosine of negative 7 pi over 6. So we would have to find negative 7 pi over 6 the same way that we did on the unit circle. So it's different than positive 7 pi over 6. We would go in the negative direction. So we're looking at this point here, which again is the same as our coterminal angle there. So just remember you're going in the negative direction to find that. So cosine tells us that we have to look at the x coordinate. So negative square root 3 over 2. So negative 1 times negative square root 3 over 2 would be positive square root 3 over 2. And then for our y, we have y is equal to negative 1 times sine of theta, so sine of negative 7 pi over 6. So we're looking at the y coordinate, which is 1/2. So y is equal to negative 1 times 1/2, which would just be negative 1/2. So our rectangular coordinate point is square root 3 over 2, comma negative 1/2. Which, looking at our graph, if we go to the right, so if I made this a rectangular plane, I'm going to the right, square root 3 over 2. Doesn't really matter how much because we're just figuring out kind of what coordinate, making sure we plotted it in the right point and did the math right, just double checking our work. So we would go in the positive direction and then down 1/2, which would put us in the fourth quadrant. So that's just a way you can check your work to figure out if your point ended up in the same quadrant that it should be in. So plot the given rectangular point. So I'm going to stay at 0 and go down 8. So that would be our first graph here. And then we have to find two sets of polar coordinates for the point where theta is in between 0 and 2 pi. So we want to convert this point into rectangular, or to polar. It is rectangular, we're converting it to polar. So to find theta, we can use tangent of theta is equal to y over x. So tangent of theta is equal to, this would be negative 8 over 0, which gives us undefined, right? So we want to see where y over x gives us undefined on the circle, on the unit circle. So looking at our unit circle, we're looking for where our x value is 0. So where is our x value 0? Pi over 2, and where else? 3 pi over 2. Looking at my rectangular graph, which one do you think correlates to this point here? 3 pi over 2. I'm going to pick this one because we want to go down in the negative direction. So theta is 3 pi over 2. Now we still have to find r. So to find r, we use r squared is equal to x squared plus y squared. So r squared is equal to 0 squared plus negative 8 squared. R squared is equal to 0 plus 64. So r squared is 64. We take the square root. What is r? 8. We would say plus or minus 8, but if we are going to 3 pi over 2, if we're looking at this point on our polar one, our polar graph where we have all the rings and stuff, would I have to, if I go to 3 pi over 2, would I have to go negative or positive 8 rings out? Positive 8, because I'm going to 3 pi over 2. So here, my point would be 8, comma, 3 pi over 2. If I went to negative 8, what would my theta have to be? Pi over 2. So these would be our two rectangular coordinates. So you could just use the positive 8 and the negative 8. But think about it how you had your polar coordinate here. If I go to 3 pi over 2, 8 rings out would be this way, which puts me in the same spot as my rectangular graph. If I went to pi over 2, I would have to go in the negative direction, so negative 8, to be in that same spot as the rectangular graph, that same point here. So use the rectangular graph to help you figure out where exactly you need to be. So we want to plot the given in rectangular coordinates. So it may be hard to see where 2 square root 3 is, but just figure out which quadrant you should be in. So we're going to go to the right, 2 square root 3, and down 2. So that's actually 2 points that end up in that spot. So let's figure out what 2 square root 3 is. What's square root 3 about? 1.5. So is it gonna be 4 something, or is it gonna be 2 or 3 something? 3 something, because 2, it would have to be 2 times 2 in order to give us more than 4. So it's gonna be 2 times something less than 2, so it puts us less than 4. So that would be where we are at. Now let's convert it to polar. So we can start by finding r first. So r squared is equal to x squared plus y squared. So r squared is 2 square root 3 squared plus negative 2 squared. So this would be 4 times 3, which is 12, plus 4. So r squared is equal to 16. So what is r? Plus or minus 4. So because we're going to come up with 2 points, let's say we have a positive 4 and a negative 4. So now let's find our theta. So tangent of theta is equal to y over x. So tangent theta is equal to negative 2 over 2 square root 3. So this would be negative 1 over square root 3. So we want to find on our unit circle where tangent of theta is negative 1 over square root 3. Remember, tangent is y over x. You don't really have to rationalize it because we're going to end up looking at the radians of it and not like, so we have to figure out where it's negative 1 over square root 3. So if you rationalize it, you're going to have to rationalize it again when doing the work. So tangent is negative in this quadrant, the second, and in the fourth. So we're going to look at those two. Let's start in the second quadrant. So we want to figure out where y over x is 1 over square root 3. Well, it's either going to be 5 pi over 6 or 2 pi over 3, because that's the one that has the square root 3 in it. So let's figure out where y over x is 1 over square root 3. So here we have 1/2 over negative square root 3 over 2. Keep change flip. So this flips to 2 over negative square root 3. Perfect. It's this one. Yay. So we're looking at 5 pi over 6. Yes. So would 5 pi over 6 go with the positive 4 or with the negative 4? So on my polar one, if this was a polar thing, 5 pi over 6 is in this direction over here. So would I be going in the positive direction, or where's my point? Negative, so we have to go in the negative direction. So 5 pi over 4 is going to go with the negative. 5 pi over 6 is going to go with the negative 4. Yes.
So you basically always go in the opposite direction as for the previous one, so you did the same thing with the 0, -8.
It's not always in the opposite direction. You need to figure out where your point is. So my point's there. We found that first, our rectangular point. So if we're going to just picture our polar coordinate thing on here, so 5 pi over 6, looking at our unit circle, is out in the second quadrant. It's this way. But my point is in the fourth quadrant. So instead of going out 4 rings this way, I need to go in the opposite direction 4 rings. So that's why 5 pi over 6 is going to go at the negative 4. We have another value on our unit circle that also gives us tangent of theta is equal to negative 1 over square root 3, which is going to be, if we draw a straight line here, it's going to be 11 pi over 6. You can do that by taking this point and doing y over x. So negative 1/2 over square root 3 over 2. Keep change flip. So again, this is negative 1 over square root 3, which is what we were looking for. but it's always going to be the straight line to it. So if I put 11 pi over 6 as my polar line here, I'm going to go in the positive direction 4 rings or in the negative direction 4 rings. Positive direction. I go in that direction of 11 pi over 6. So since we go in the positive direction, it's going to go at the positive 4. So these would be our 2 points.